So logarithm is a very important function, and it is the inverse function of exponential function. So one can define log with the help of exponential functions also. Now a general aspect is that if you have a graph of a function and you want to find the graph of an inverse function, then what should you do? I'll take this particular example of exponential function and logarithmic function to explain you this thing. So as a general rule, this is my exponential function where this point is 0, 1. What will be the log function which is actually inverse of this function? Now what you do is you draw a line y is equal to x. You draw a line y is equal to x. And what you do is take the mirror image of this graph with respect to y is equal to x line. So what will happen? If I take the mirror image, this will become like this and so on, like this. This is a mirror image of this graph of exponential function with respect to line y is equal to x. And this graph basically represents log function. And the base will be same as of this graph. So if it's 2 to the power x, then the base of log will be 2. If it's e to the power x, then normally we write it as ln. So that's how, in fact, it's a general rule, not specifically, not particularly true for the exponential function and logarithmic function. Wherever you have to draw a graph of an inverse function, what you do is you draw a line y equal to x, take the mirror image of the main graph, and that will give you the graph of inverse function. Now let's take some properties of logarithmic function which are very, very important. First property is log of a into b. Now here you have a base also, but this property is true for any base. So log of ab is equal to log of a plus log of b, whatever the base is, irrespective of that base. Second property is log of a by b will be equal to log of a minus log of b. Then third property is log of a to the power b will be equal to b log a. Now this third property is very, very useful in case of a differentiation when the power is variable. So if you want to differentiate x to the power x or sin x to the power x or any function to the power of some function, then that's the only way, this is the only property which you have to use in order to find the differentiation. Now the fourth property is log of base. If you have a base a and here also you have a base, the argument is a, then the answer will always be 1. So if the base and the argument of a logarithmic function is same, then the answer will always be 1. Now the last property, which is actually changing the base of a logarithmic function. Why it's important? Because if you see your calculator, there are only 2 logarithmic functions available in your calculator. One is the base 10, another base e. One is known as a common logarithmic. Now in this case, how to change the base? If you have to calculate, suppose base 3, logarithmic with base 3. Now in your calculator, because you have only 2 bases, there is a 10 and the e, therefore you have to convert that base to another base. So in general, how to change the base of a log into another base? So if you have a log base a, let's say x, and I want to change the base to maybe some other number, let's say b, what will be my answer? So it will be log base b x divided by log base b a, old base. A is my old base. So with the help of this, if you have a base 3 and you want to calculate, let's say 20, so argument is 20, base is 3, that's not there in my calculator. What I can do is I can change the base to maybe 10, maybe e, and then I can calculate this using my calculator.